भी बताना चाहिए ना। वो खुद बोला। क्या बोलो? ना बोल रही मैं। बोलो। किसमें? ब्यूटी में ना। ग्रेजुएशन क्या पूछ रहे तुम? किस में? हाँ उसमें ले लो, उसमें तो उसमें एग्जाम दे सकते हैं सीटर। हाँ तो कर लो। तो दे दो, ठीक रहेगा।
Good morning to all of you.
गुड मॉर्निंग सर।
Good morning, sir.
Good morning, sir.
Good
Good
morning,
morning.
sir.
Morning, sir.
Good morning, sir.
Good morning, sir.
Good morning. Now, today we will start generalized mean value theorem and also some problems on generalized mean value theorem with Lagrange's form of remainder and Cauchy's form of remainder. Besides this also, if time is available, I shall start radius of curvature. If time is available. Okay. Now, just although we are just 5 minutes before, from 9 I shall start. Okay.
Good morning, sir.
Good morning. Good morning. Now, our today's discussion is generalized mean value theorem. And before starting it, some discussion, some conditions has to be discussed. Generalized mean value theorem. Sometimes it is known as Taylor's theorem. Already in case of Lagrange's mean value theorem, we have seen that f of b, that is f of a plus h, equals to f of a plus h into f dash a plus theta h. Means in the second term you have taken the remainder term of the error term. This remainder is the difference between the actual function f of x and the polynomial expansion of the function. Now if we take the remainder term or the error term in n plus 1th after nth term, then what will be the situation? Then also f of b equals to f of a plus h, that is equals to f a plus h into f dash a plus h square by factorial 2 into f double dash a. In this way it will go h to the power n minus 1 by factorial n minus 1 f of n minus 1 a plus h to the power n by factorial n fn a plus theta h. Now what are the conditions for this particular theorem? Now we will discuss about the conditions that are applied for the particular theorem.
Excuse me, sir.
Yes,
Sir, in the Taylor's theorem, which is the remainder in the mean value expression?
yes, this is the remainder. This is the remainder, and there are different forms of remainder. We have to go through Lagrange's form of remainder and Cauchy's form of remainder, and this is the Lagrange's form of remainder. We will prove it also how it comes. Okay.
Okay, sir.
Uh, this is Lagrange's form of remainder, or the error term, that is the difference between the actual function f of x and this expansion. This is the difference. Okay.
Excuse me,
Now,
sir.
hmm,
Sir, I am not added in the team for mathematics classes in MS Teams. I am not a member of that group, MSC01.
okay. You just send me one mail, then I shall add you. Okay.
Okay, sir.
Hmm. Now, question is that what are the conditions that are imposed for this particular theorem? Number one condition is if f of n minus 1, means n minus 1th derivative is continuous. Is continuous in the closed interval a plus h. Then if f of n minus 1 is continuous, then obviously f dashed, f double dashed up to f of n minus 2 also continuous. So from this you can draw the conclusion that if you form a function like phi of x which contains f dashed, f double dashed, all addition with those derivative up to f of n minus 1, that function also continuous. Now the second condition is fn exists in the open interval a plus h. Then question is that if this very particular f dashed, f double dashed, all are continuous and also it is derivable, then the last condition of the Rolle's theorem, that if you form a function phi x equals to f of x plus a plus h minus x. Why a plus h minus x? I am just telling f dash x, a plus h minus x whole square by factorial 2 f double dash x up to a plus h minus x to the power n minus 1 by factorial n minus 1 f of n minus 1 x. Look at the last term. Last term is a plus h minus x to the power n by factorial n into sorry, a plus h minus x to the power n into capital A. Look at this. Here f dash x involved, f double dash x involved, up to f n minus 1 involved. All are continuous, as f of n minus 1 is continuous. So f dash, f double dash, all are continuous. Now here look at this equation. For every term, f dash, f double dash are multiplied with a plus h minus x whole square, a plus h minus x to the power n minus 1. So if you put x equals to a plus h, all the terms will be 0. Is it true or not?
Yes, sir.
If you write that
Yes, sir.
phi of a plus h, obviously it will be f of a plus h,
Yes, sir.
and all the other terms will be 0.
Yes, sir.
Number 2 is, if you put phi a, mute, all mute yourself. If you not mute, I have to mute.
Sir, what is A? Capital A?
Yes,
We
a
get
is
the
some
Taylor's
a is be the initial value. A plus
theorem.
h is the Taylor's theorem. A plus h will be the final value b, because b minus a equals to h. Okay.
Capital A, sir.
Sir,
Now,
capital A.
Capital
Sir,
A,
how
sir.
we represent phi x in
I
this
am
way?
coming. I am coming to capital A. Okay. Okay. Now, if you put phi of a, look at here. F of a plus h minus a, that is h into f dash a, h square by factorial to f double dash a, h to the power n minus 1 by factorial n minus 1, f of n minus 1a, and look at the last term. H to the power n, if put x equals to a, h to the power n into capital A. So if you match with the previous, that if you can prove that capital A is n a plus theta h by factorial n, then it can be proved.
Yes,
Then
sir.
it can be proved, and also as well as the Rolle's theorem can be imposed on it. Now you have enough option to supply the value of capital A externally. So you can easily assume that you have put the value of capital A in such a way so that phi of A equals to phi of A plus H. Then on phi x, you can conclude that all the conditions of Rolle's theorem is satisfied. So phi dash c equals to 0. Phi dash c equals to 0. And if you calculate phi dash x, what will be the situation? You see that f dash x, if you consider it uv, then you see this will be minus of derivative of this will be minus 1 minus of f dash x. So if you conclude that phi dash x, here it will be f dash x, this will be u, so it will be minus of f
F
dash
double.
x,
Yes.
minus of f dash x, then this is unchanged, a plus h,
And F double dash.
a plus yes, f double dash x, f double dash x. Now if a plus h minus x, f double dash x, then look at the last term and the next term, it will be a plus h minus x. So if you consider it as u, then you can consider it 2 into a plus h minus x by 2. In this way, this will be f double dash x, so it will be minus 1. So this is also cancelled, this is also cancelled. In this way, all are cancelled. Which will remain?
Last term.
Last term will remain.
Yes. If this will be converted to fn, if a plus h minus x to the power n minus 1 by factorial n, this portion is unchanged. If it is fn, then in the next term there is no term to dilute or to cancel fn. Okay. So you can easily conclude that the last two terms, that is a plus h minus x to the power n minus 1 by factorial n minus 1. If this is u, f of n x, this cannot be cancelled, minus the last term n into a plus h minus x to the power n minus 1 into capital A. This is equals to phi dash c equals to 0. Okay. So from here, you can easily conclude that what is the value of A, or a plus h minus x to the power n minus 1 by factorial n minus 1 f of n, suppose it is a plus theta h, equals to n into a plus h minus x to the power n minus 1 into capital A. Now this will be cancelled. This a is multiplied here. So capital A is here fn a plus theta h by factorial n, which is the Lagrange's form of remainder. All of you quite clear about this? How it comes?
Yes,
Sir,
sir.
how phi a
Yes.
equals to phi a
Yes,
plus
sir.
h?
Yes.
Yes,
How?
sir.
Yes.
Sir, sir, A is the remainder for Taylor's theorem.
A is the remainder for Taylor's theorem, but Lagrange's form of remainder.
Okay, sir.
Okay. Now how it comes? How it
Sir.
comes?
Sir, why derivative equal to 0?
Sir, one second.
Yes. Good question.
For applying rule.
Applying Rolle's theorem.
Sir, please.
That you have already assumed that f n minus 1 is continuous. So all are continuous. F dash, f double dash, all are continuous. Now using this continuous function, you have created a function phi of x. You have created the function phi of x. So phi x is continuous. Phi x is derivable. Phi x is continuous. Phi x is derivable. Then there is no option how phi dash c equals to 0. You have seen that phi x is equals to f of x plus a plus
Sir,
h
your voice
minus.
is the cutting.
Oh,
No, sir.
No, sir.
No,
Clear.
sir.
it's
sir,
a
clear.
plus
Sir,
a
it is
plus
clear.
h
You can continue.
minus x into
Yes.
f dash x. Now in this way, look at here that the last term, that will be a plus h minus x into capital A to the power n into capital A. A plus h minus x to the power n into capital A. So you can supply the value of A according to your desire, and you have assumed that phi of A equals to phi of A plus h. So on phi x is continuous, phi x is derivable, and also phi of A equals to phi of A plus h. So on phi A, you can apply the Rolle's theorem. So phi dash
Yes, sir.
c equals to 0. In that way, you have calculated phi dash x, and when you calculate phi dash x, all the terms will be deleted. Only the term when you calculate f of n, in the next term there is no term to cancel f of n.
Cancel it, yes.
So you can easily obtain the value of capital A. That capital A is this. This is the Lagrange's form of remainder. Okay.
Yes, sir.
Next.
Sir,
Hmm.
So, sir, in this condition we have assumed.
what is meant by remainder?
Yes. Remainder is the difference between the actual value of f of x and the polynomial expansion that you have done. That polynomial
So that means
expansion,
phi x minus f(x).
that is phi x that you have expanded. You have expanded by a polynomial, na? You have expanded
Yes,
the
sir.
function by a polynomial, but there is some error. That error is the remainder. Okay.
Sir, here
And-
n
Okay,
is
sir.
the degree of the function, right?
Sir, please show the conditions once
Sir,
again.
n is the here
Hmm.
n is the degree of the function, right?
Hmm.
N
f of n is will be the you have calculated the nth derivative, na?
And
Sir, then remainder should be f of n plus 1th term, na sir? F of n plus 1 into a plus h minus x.
N plus 1th term. Yes, n plus 1th
Yes,
term.
sir. N plus
Then
f of x
term-
is there now.
then why the remainder we have written by f of nth into a plus
this is the expansion, na? This is the expansion. First is f of x. Suppose, just 1 minute. You have calculated phi of x. That will be f of x plus a plus h minus x into f dash x. In this way, why you are proceeding? Because already you have given the condition that f dash x, f double dash x all are continuous, and the term before the last term will be a plus h minus x to the power n minus 1 by factorial n minus 1 f of n minus 1 x, and the last term you have taken a plus h minus x to the power n into capital A. You have the option to give the value of capital A, so that you have assumed that phi of A equals to phi of A plus H. Phi of A plus H is f of A plus H, because A plus H minus A plus H, A plus H minus A plus H. So phi of A plus H is f of A plus H. Already it is obtained. Phi of A is f of A, H into f dash A. That's same, Taylor's theorem. F n minus n. What? Look at the last term. H to the power n into capital A. So if you can prove capital A is Fn A plus theta h by factorial n, then it is proved. Lagrange's form of remainder is proved. Okay.
So
Just
can you
only
show the slide one more? At the bottom, sir. At the bottom, sir.
Sir, why have you chosen variables like a plus h minus x? Like in the previous generalization which you gave in the previous class, you have written f of a plus h into f dash a plus h square by 2 factorial f double dash a. So why here?
Why I have written a plus h minus x?
Yes, sir.
Yes. Here the last condition of Rolle's theorem is not given. F of a equals to f of a plus h. This is not given. You have to impose Rolle's theorem, then you can only prove this. When you want to impose Rolle's theorem, you just form a function with f dash x, f double dash x in this way. Okay. Then this
Sir,
function
I
phi
didn't get
x.
that.
Okay. Your condition is given f of n minus 1 is continuous.
No, sir, I am asking about generalized MVT. There is
General
some problem in that I want to ask.
f of a plus h equals to f a plus h into f dash a in this way, h to the power n by
So, sir,
factorial.
here we are expanding f dash a plus theta h in the form of f dash a plus.
No. You are not expanding. F of b you are expanding, because if you go for the first class, then you have seen this, that f of f dash c equals to a b minus f a by b minus a. That you have seen. What is being?
Yes, sir.
So f b minus f a, b minus a is h. And what is
Yes, sir.
c? C is, suppose this is a, this portion is a, then this is b, this portion is n
Sir,
into
I know
theta.
this thing.
Then f
F a
dash
plus h equals to f
a
a
plus
plus h f
nah,
dash a plus
nah,
theta
A plus
h.
theta h.
this is f
How
b.
you extended this sum to this whole
This is the
theorem?
generalized form. This is the generalized form.
Sir, Taylor.
Established theorem.
My
So there
question.
is no way to go
Plus
to
h
that theorem
minus
from
x f
this
dash
theorem.
This is established theorem, Taylor's theorem, by which you
No,
can
Taylor's
expand.
theorem is f of x plus h into f dash x plus h square and h square by 2. That no, so he's asking how did you turn the Taylor's theorem into here? You took a plus h minus x instead of h, and a
Yes.
plus h minus x
This,
whole square.
yes. Good question. This you have made a function continuous. You have made this. You have created this function to prove it. You have created the function phi x in such a way so that it is continuous, it is derivable, and the last condition phi a equal to phi a plus h is not given. You have created that a plus h to the power n into capital A, so that you have enough option to give the value of capital A, so that phi of A equals to phi of A plus h. This is
Sir,
you
I
have
am
assumed.
asking there is
This
no need
you
to
have,
prove Taylor's theorem now. It is
no.
established. There is no
It is
need to prove
established.
it.
No, but
We just need to remember it.
but Lagrange's form of reminder, Cauchy's form of reminder, how it comes, that you have to prove, na?
Okay.
That you have to prove. So that
That means this is a generalized form to find the
generalized form, but reminder when you obtain, how reminder you have to obtain? A plus h minus x to the power n into capital A, then you obtain the Lagrange's form of reminder. Okay, fn a plus theta h by factorial n h to the power n into. Okay, h to the power n is already available here, and only you have obtained the value of
What is
capital.
this remainder, sir? What is this remainder term? What do you mean by this remainder?
Reminder is this is the polynomial expansion. This is the expansion of the function, and the actual function f of x. There is some error in between these two. This is the reminder. Okay.
Okay.
And which form it will give, that can be proved by this formula. The same formula can be used for Cauchy's remainder also. The same logic. Nothing.
Sir.
No need to know more. Only just this same formula can be used to get the concept of Cauchy's form of reminder.
Sir, if I put here n is equal to 0, it will give LMVT, Lagrange mean value theorem.
At the time of a plus h minus h
Sir,
into
is
f dash
a
t.
the only remainder or the whole term, like f of a plus h minus x whole per n by n factor into a is the remainder? Only a is the remainder, or the whole term is the remainder?
Whole term is the remainder. Whole term is the remainder. H to the power n by
Can we also prove
factorial n.
Factorial.
Okay, there is some
A.
problem. H to the power n by factorial n f of what is come. H to the power n by factorial n fn a plus theta h. Then the same formula can be, this is Lagrange's form of remainder. Lagrange's form. Now the same formula can be used for Cauchy's form of remainder also. Suppose you consider phi x equals to just like the same fx plus a plus h minus x into f dash x. Same formula. A plus h minus x to the power
p.
n minus 1. Yes,
N
yes,
minus
to the
1.
power p is the to the power n minus 1. To the power p is the generalized form. N minus 1.
Snowman's form.
F of n minus 1 x. And the last term, if you take that a plus h minus x into capital A, where p is 1. In the previous case, p is n. Here, if you take p is 1. Then what will be the situation? Just like the previous, all the terms will be cancelled. In case of phi dash x, all the terms will be cancelled. What will remain? A plus h minus x to the power n minus 1 by factorial n minus 1 f of n x, and derivative of this will be minus 1 minus a, that is equals to 0. So a is equals to a plus h minus x to the power n minus 1 by factorial n minus 1 fn x. Now you have to simplify it, because in the book, if you have seen that representation is quite different. Here you just simplify it. A plus h. What is the value of x? A plus theta h. Minus a minus theta h to the power n minus 1 by factorial n minus 1 fn a plus theta h. A plus theta h. Now here this a cancelled. So you can easily conclude that it will be h to the power n minus 1 minus theta to the power n minus 1 by factorial n minus 1 fn a plus theta h. But look at the last term.
Theta is very small.
Here is only one h is remaining, because if a plus h, if put x equals to a, then it will be h into capital A. So this h to the power n minus 1 will be converted to h to the power n. Yes. So it will be h to the power n 1 minus theta to the power n minus 1 by factorial n minus 1 fn a plus theta h. This is known as Cauchy's form of remainder. So only the last term.
How it comes h to the power n? Can you repeat?
Yes.
Or n, sir, please once more tell.
Yes. Here
Sir.
the last term is different. In
Sir.
the previous case, a plus, yes, 1 minute. I'm just giving the answer, then I am hearing what you are telling. A plus h minus x. Okay. If you put here x equals to a, then it is h into capital A. Is it true or not? H into capital A. Now here it is coming h to the power n minus 1. H to the power n minus 1. So h into h to the power n minus 1, this is h to the power n. 1 minus theta to the power n minus 1 by factorial n minus 1. Fn a plus theta h. Okay.
So we are finding HA.
Okay, sir.
We are finding the Cauchy's form of remainder after nth term. Cauchy's form of remainder after nth term.
Sir?
Okay.
So sir, the last term you have written is the value of A or HA?
H into A. That will be the remainder term. As a whole, it is remainder term. Okay.
Sir.
Yes.
Sir, can you please disallow the reactions? Some people are spamming the reactions. It is causing a distraction.
Yes, sir. What do you think?
Block everything. It will be problem for you.
Look, sir. Sir, I have one issue regarding the we have our continuous assessment exam on next Tuesday on Moodle, but many of us has yet not able to set up it. We have mailed regarding that to the concerned email ID, but no reply had yet come.
I shall take through MS Teams on my group. I shall take through MS Teams.
LKD sir has posted that he will take this continuous assessment test on 11th, but actually the problem is many of us has not been able to solve that. Actually, the registration is not completed for many of the students, but the mail ID which has been provided to us from where we have to contact regarding this, we have mailed. I himself, myself has mailed on 19th of December, but yet no reply had come from it. Actually, after creating the account, the activation link which was supposed to be sent to our institute ID is not coming. And yesterday night, I again tried, and then it was showing that the login credentials were invalid. When I tried to reset the password, they showed that a confirmation mail is sent to your ID, but no ID was there, even not in the spam folder.
Then
check your personal mail.
I shall take through MS Teams.
Okay, sir, but if you kindly could address about it, it will be of much help. Many of us are facing.
Okay. Are you ready for to face exam through MS Team? Through MS Team, you have no problem.
Yes, no, sir. MS Team is working quite well.
Okay. Then you just.
Sir, in Moodle, I am also facing a very similar issue like that. It's not coming to the institute mail ID, that activation link.
Okay. You just tell to HOD, LKD sir. Okay.
So what is the syllabus for CO1 for math?
You take your problem. You just tell your problem to HOD sir. Okay.
Sir, what is
Sir, what will be the syllabus?
Sir, what is the syllabus and question pattern of CA1, sir?
Yes, sir.
And timetable, sir. Timetable has also not given it.
already I have the portion that will cover that portion also. Only after that.
And sir, the question pattern means how many questions will be there?
So question
Total 15 marks. It may distributed between 10 questions or 15 questions.
Sir, will it be MCQ or subjective?
MCQ.
Sir, these all details please send me in the MS Teams, sir.
Okay, I shall.
What is the syllabus and what pattern of the examination?
We don't know the schedule of the paper. We don't know which syllabus we have.
Sir, can you send a sample of CA1 so that we can get an idea about an exam?
Yeah.
Yes, sir.
Sir,
Yes, sir.
how much time
Yes,
do
I-
we get to write
Will be a
the
great
exam?
hall.
Because
Half an hour.
because before examination, before examination, this will be my last class. LKD sir's class also remaining. You just tell him, okay, that you are quite comfortable through MS Teams. Then he will take it through MS Teams also. Okay, or he will decide accordingly. HOD will decide.
1 hour exam.
No, half an hour. Only 15
Half
marks.
an hour. Oh, okay, sir.
Now I have to start. Okay, just I'm starting the next portion.
Okay, sir.
Sir, please move to the page.
Sir,
Now we will discuss some problems. Suppose you just write the problem. If f of h equals to f of 0 plus h into f dash 0 plus h square by factorial 2 into f double dash theta h, where 0 less than theta less than 1, then prove that theta equals to 9 by 25 when h equals to 1. Now here you see, you have to consider it is given in the problem that fx equals to 1 minus x to the power 5 by 2. So f of 0 is equals to 1. What is f dash x? F dash x equals to 5 by 2, 1 minus x to the power 3 by 2 into minus 1. So f dash 0 is minus of 5 by 2. So x or h into f dash 0, that is also minus of 5 by 2 because h is 1. Now f dash theta h, as h is equals to 1, first of all f double dash x is you obtain, that will be 5 by 2 into 3 by 2, 1 minus x to the power 1 by 2, 3 by 2 minus 1 into minus 1 into minus 1, that is same. So it will be that h square by h is 1 by factorial to 2 into 5 by 2, 3 by 2, 1 minus theta into h. Theta is theta, h is 1 minus theta to the power half. So you can easily write that 1 minus x, 1 minus 1, so f of h, that is 0, equals to 1 minus f dash 0 plus 1 by 2, 5 by 2, 3 by 2. So it will be 1 by 2, 5 by 2, 3 by 2, 1 minus theta to the power half. So it will be 1 minus 5 by 2 minus 3 by 2. That will be taken this side, left side. So it will be 3 by 2 equals to 1 by 2 into 5 by 2 into 3 by 2, 1 minus theta to the power half. So you can easily write from this that, so it will be 5 by 4, 4 by 5 equals to 1 minus theta to the power half, or 16 by 25 equals to 1 minus theta. So theta equals to 1 minus 16 by 25 by 25. Is it clear to all of you?
Sir,
Sir, there
sir,
will
in
be
this
a minus
question,
1
what
in the
was
Double
given and
derivative path
minus 1 will be in
One by
second
one.
derivative, because 1 minus x will be derivative as minus 1.
1 minus x into 1 into already
Minus,
previously, minus 1 is already present.
no sir, for the second derivative.
Wrote 1 by 2, no, sir. F double dash theta.
So
Then
Second derivative, sir. Second
So
derivative.
there's an
Sir, why
extra
he
There
has
1
will
by
be
written
a
2
this
over the
minus
half?
1.
yes, sir,
calculator, sir,
extra
you
1 by
wrote
2.
1
How
by
is
2,
that
that
1 by 2
was
will
The
come?
1 by 2 will
Minus 1
not
into
be there,
minus
and it
1.
will 1 minus theta x. Sir.
That will be
Yes,
same.
right.
Yes, sir,
Now
the
this is
sign is okay. But in this, yeah, this 1 by 2 should not come.
1 by 2 is 1
Sir, it doesn't.
h
1
by
by
h
2
square
x
by
square by 2 factorial.
oh acha.
1 by 2 is
Yes,
2
yes,
factorial.
yes,
So
h
1 upon 2
square by
factorial.
factorial to
2
f double
factorial.
dash theta is, yes, that you have to write. Okay, h square by
Oh,
factorial.
okay, okay, sir.
That you have to just, I have included. Okay, now theta equals to 9 by 25.
Sir, the question was f of h, no?
f of h is this the expansion, but you consider fx equals to 1 minus x to the power 5 by 2. You have to prove it, that
Sir,
theta
fx
equals
equals to 1 minus x power 5 by 2 is given in the question.
given in the question. It will be given, it must be given, otherwise how you can obtain? Okay.
No, sir, we have taken h is equal to 1, no? So
H
f of
equals
h.
H equals to
Sir, what was to prove? Sir, theta equals to 9 by 25 was the question. Once we had to prove.
that you have to prove. Theta equals to 9 by 25. Okay.
Okay, sir.
Sir, remainder
So,
of.
sir, we are substituting x with theta h and then h is equal to 1, right?
Sir,
Consider
the
H
resistance
equals to
of
1.
Taylor's theorem and Cauchy's theorem and the Lagrange's mean value theorem are different.
No, theorem is
Sir,
same.
how the
Remainder term you are defining. Cauchy's form of remainder, Lagrange's form of remainder, generalized form of remainder. Okay. In your syllabus, Cauchy's and Lagrange is involved. So that in order to prove Lagrange's form of remainder, you have taken last term is a plus h minus x to the power n into capital A. You have proved Cauchy's form of remainder, a plus h minus x into capital A.
Sir,
Nothing.
one thing. Sir, the role of
Why
remainder is basically to eliminate the error that is there in the series, na?
Actual
So how
function
can
and
he
the
be
expansion.
different?
Sir, but we understand that it is used for eliminating the error, but how it is eliminating, like how it is happening, like you have proved, but the field that is there, that it eliminates
You
the
have
error.
now we
That,
have
And
proved by
how
using
different
Rolle's
reminders are
theorem.
coming for different equations?
Yes, because you have taken, you have seen that in the change that you have made in the last term. When you are making a function phi x, you have enough option to supply the value of capital A, and the change you want to different take forms. You have made the change at the last term, so that according to the changing that you have made, the different forms of remainder you are coming. This is nothing but the forms of remainder in the series. Okay.
How you taken that f of x equals to
Maclaurin's
1 by
theorem
6
also.
Now we
Sir,
have to
how
just
did we
discuss
get
the
the
next
extra
problem.
half?
Sir, can you show the screen, the upper part of the screen?
Is equal to 0.
So how did we get the extra half?
Okay, so thanks.
Extra half, that will be h square by factorial 2. H is 1. 1 by factorial 2, that is 1 by 2. Okay, that is this portion, h square by factorial 2. This, so that this half is coming.
How it is 1 minus theta?
How it is equals to 0,
Yes.
sir?
1 minus theta, because 1 minus theta is theta into 1. That is 1 minus theta.
H equals to
H equals to 1. Considering h equals to 1. And fx equals to 1 minus x to the
Sir,
power.
and one more thing, we
Yes,
can
sir.
decide now how much we will continue the series, up till which number?
Yes, good question. You have seen different problems, and you have seen also just I am just in the last class I have shown one problem, that in the next third term, you have taken the remainder. Why? Because on the basis of the value of theta, as theta ranges between 0 to 1, you have the option to prove the inequality. Okay, so seeing the problem, you have to decide that in which time you just fix the remainder. That will be given in the problem. Seeing that, you have to stop there. You have to take that.
Sir, till the value of differentiation comes equals to 0, means if double dash 0 equals to it is coming 0, then we can equate the equation and take the value.
No, that you have to decide. I am telling that in which time you stop. Suppose one inequality is given. In which time you stop, that you have to decide from the problem.
Question itself.
Equation.
Sir,
that will be
because
given.
the remaining terms will be negligible, that's why we are stopping there, sir.
No, you have to take the remaining term. Yes, term is gradually decreasing. Yes, but you have to decide from the problem that where I stop. Where I stop. That may be.
Sir, this depends on the degree of x also, means the where we have to stop.
Degree of x will tell you where you stop.
It will be given in the question,
yes,
sir.
Yes. This point just I am discussing. 1 minute. This is known as Maclaurin's expansion. Okay. This is known as Maclaurin's expansion, where the interval that you have taken, that is the interval that you have taken 0 to x. Then a is 0, b is x. So f of x can be expanded as f of 0 plus h, that is x minus 0, that is x into f dash 0, x square by factorial 2, f double dash 0. This is known as Maclaurin's expansion with Lagrange's form of remainder, x to the power n, h to the power n by factorial n, fn, a plus theta h, a is 0, theta h plus theta x. So here Rn is x to the power n by factorial n fn theta x. This is known as Maclaurin's expansion with Lagrange's form of remainder. Similarly, Maclaurin's expansion, Cauchy's form of remainder is x to the power n by factorial, anyone? n minus 1. 1 minus theta to the power n minus 1. Fn theta x.
Yes.
This is Maclaurin's expansion with Cauchy's form of remainder. This is Maclaurin's expansion with Lagrange's form of remainder, where nothing else, you have changed the interval from 0 to x. Okay. Is it clear?
Sir, but we don't use x to the power n in Lagrange form of remainder.
Yes.
So we don't
So
use
in
x to the
place
power
of
n in Lagrange form of remainder. It's only fn a plus theta h upon n factorial.
Fn But the last term. 1 minute.
Yes, sir. So A is the remainder in this question. Matlab, you have
No, the
explained
whole
everything
term.
in terms of
Sir
A.
said
No, no,
it's the whole
no.
term.
Whole term. I have told na the whole term. A plus h minus x to the power n into capital A. You have obtained the value of capital A as fn a plus theta h by factorial n.
Yeah,
But if
factorial.
you put here a, then if x equals to a, then it will be h to the power n. Na? As a whole, the
Okay, sir.
last term will be h to the power n fn a plus theta h by factorial n.
Okay,
Okay.
sir.
Okay. Next, now then we
See,
discuss.
if it is n minus p, then it is Snowman's George form.
Then I am just discussing the next problem. Okay.
Is coming. Yes, sir.
Suppose fx is equals to 1 plus x to the power 1 by 5. You have to prove the expansion is 1 plus x by 5 minus 2 by 25 x square. Obviously, it is Lagrange's form of remainder as well as the expansion. From this expansion, you have to consider that how much you go. 125, 6 by 125 x cube and minus 42 by 1250 1 plus theta x 1 plus theta x to the power minus 19 by 5. Okay. Now here you have to obtain how long f0 x into f dash 0 x square by factorial 2 f double dash 0 x cube by factorial 3 into f triple dash 0 x to the power 4 by factorial 4. Sorry, this is x to the power 4. X to the power 4 by factorial 4. If here you stop, take the Lagrange's form of remainder in this term. So first of all, you obtain the f0, that will be 1. F dash 0 1 by 5 1 plus x to the power 1 by 5 minus 1. So it will be, you just write 1 by 5 into 1 plus x minus 4 by 5. Here x into f dash 0, now you can easily write x into f dash 0, that will be 1 by 5. Sorry, x by 5. Similarly, f double dash 0, it will be that 4 by 5, 1 by 5 into minus 4 by 5, minus 4 by 5 minus 1, so it will be 1 plus x minus 9 by 5. And here x square by factorial 2 f double dash 0 will be, you just write that minus 4 by 5, so 1 by 2 x square by 2 into 1 by 5 into minus 4 by 5 minus 4 by 5, then here it put 0, so it will be 1, so it will be 2 minus 2 by 25 x square. Okay, so similarly you just obtain the next term. If triple that 0, that will be 1 by 5 into minus 4 by 5 into minus 9 by 5, 1 plus x to the power minus 14 by 5. So here if you write that x cube by factorial 3, that is 6 into 1 by 5 minus 4 by 5 into minus 9 by 5, 1 plus x, that will be 1. So you can easily obtain that it will be equals to 6 by 125, 6x cube by 125. Now the last term, here you fix the remainder in Lagrange's form. Now f4 theta x, f4 theta x, because 1 plus theta x here, so f4 theta x, what is the value? First f4x, it will be 1 by 5 minus 4 by 5 into minus 9 by 5. Now this 14 by minus 14 by 5 minus 14 by 5 minus 14 by 5, 1 plus theta x to the power minus 19 by 2. Now 1 by x to the power 4 by factorial 4, 2 into 3 into 4 into 1 by 5 minus 4 by 5 minus 9 by 5 minus 14 by 5, 1 plus theta x to the power minus 19 by 5. Now this is coming, this series is coming, this series is coming. Is it clear?
Sir, show the last part once more.
Sir,
Too lengthy, sir.
Sir, we will get this PDF now.
Sir, I have a doubt.
sir, I have a doubt,
Sir, here,
Sir, the things you are
here,
writing, will we get this PDF?
Sir, why it is not 0 plus theta x?
Yes, function is 1 plus x, na?
Sir, please share the PDF.
In place of yes.
Sir, if I put
I have uploaded
here
it.
I can.
I have uploaded
Sir,
this
sir.
problem. I have
Sir,
already uploaded.
The series can be also obtained for the binomial theorem for any index, na? N into n minus 1 by 2 factorial,
Yes,
n into n
yes.
minus 1. But why it is needed or essential to write that?
That you are stopping there.
Again,
that you are asking.
Lagrange's.
It may be Lagrange's, it may be Cauchy's also.
Sir, if I put a is equal to 0 in Taylor's theorem, then I'm getting Maclaurin's theorem, sir. Then in the remainder of Taylor's theorem, if I put a is equal to 0,
you will get no.
Maclaurin's theorem will get. But
you have
remainder,
taken the interval
getting the remainder.
0 to x.
0 to x. You have taken a plus h, but here you are considering a is 0, a plus h is x. Okay, so h is equal to x here.
Cauchy's, so there is an example of Cauchy's remainder, Cauchy's remainder.
Cauchy's remainder already. Suppose I am showing. Yes, already you have seen that
Class of
h to the power n f of 1 minus theta to the power n minus 1 f n a plus theta h by factorial n minus 1. is h is equals to x, then it will be x to the power n 1 minus theta to the power
n
n minus 1 fn, this is 0.
Theta x, 0 plus theta x.
Now if you take fx equals to log of 1 plus x, so f dash x 1 by 1 plus x. What will be f double dashed?
Minus 1 by 1 plus x whole square.
Minus 1 by 1 plus x square.
Yes, sir.
Then what will be f n x?
Minus 1 whole power n plus 1 by 1 plus
Minus
x
1
whole
whole to the
power
power
n.
n minus
n minus 1.
N minus 1 by
1.
1 plus x whole power n.
1 plus x to the power
factorial
n.
factorial n
N,
minus 1
n minus 1 factorial by
1 by
1 plus x whole
plus
power n.
Plus x to the power.
power n.
Yes, sir.
Then what will be Rn? Cauchy's form of remainder? What is Rn? Cauchy's form of remainder? It will be x to the power n, just similar to this, x to the power n. Then 1 minus theta to the power n minus 1 by factorial n minus 1. Now this you have obtained. It will be minus 1 to the power n minus 1 into factorial n minus 1. This will be cancelled.
Yes.
1 by 1
plus
plus
x whole power n.
theta x whole power n. This is Cauchy's form of remainder.
Okay, sir. Okay, sir. Got it, sir.
Sir, still didn't get that answer.
Sir, you give us some
Why
assignment
it is needed to
before the
expand?
assessment.
Why not in binomial theorem?
This is clear? This form?
Yes, sir.
Yes, sir.
Okay, but probably I am going out of time.
Sir, can you give us some assignment before that
Sir, is
assessment?
this Cauchy's
Yes,
form of
I
remainder,
have
sir?
uploaded it. I have already uploaded this.
Sir,
Question in that.
is
Sir,
this
question.
Cauchy's
Sir,
form
we
of
need
remainder?
questions.
Oh, some sample
Practice.
questions for practicing.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
For
sir.
practicing
Okay,
only.
I shall upload it.
And
For
sir,
my
please
from
share
my
the lecture notes
The
also, sir.
syllabus
say
for the
next lecture notes
CA1.
already I have uploaded through MS
Sir,
Teams.
please send the
This one,
syllabus
sir,
and
this
lecture
one.
notes, sir, in the MS Teams.
Already uploaded. You just find out.
Thank you, sir.
Okay.
Thank you,
The
sir.
syllabus for CA1.
Sir, how much you are teaching, that much we will study for CA1.
Yes.
Thank you, sir.
Sir, is this
In-
Cauchy's form
Yes,
of
sir.
remainder, sir?
Sir, we have another class at 10 a.m.
Explain why
Sir,
the
can we clear, sir?
Okay. You may leave.
sir, can we
You may leave.
leave?
You may leave.
Download the attendance.
Thank you, sir.
Okay. Thank you.
Sir, only
Sir,
your notes can we study?
sir, share this PDF.
Already